All right, we're back. This time, we're going to go into a little bit of real-time data streaming for machine learning, focusing on Amazon Kinesis. But before we get started, hit the like button, subscribe, and share this to anyone you know who's taking the Amazon Machine Learning Associate exam. So, Amazon Kinesis. This is AWS's comprehensive suite of managed services for collecting, processing, and analyzing real-time data streaming at scale. In the context of artificial intelligence and machine learning, streaming data services enables organizations to build responsive, intelligent systems that can react to events as they occur, rather than waiting for batch processing cycles. The real-time capability is essential for modern AI applications such as fraud detection, recommendation engines, anomaly detection, and real-time personalization systems. The Kinesis family addresses different aspects of the streaming data pipeline, from initial data collection through processing and final delivery to target systems. These services integrate seamlessly with AWS's machine learning ecosystem, including SageMaker, Lambda, and analytics services, enabling the construction of end-to-end intelligent data processing architectures that can handle massive scale while maintaining low latency characteristics. Real-time streaming data differs fundamentally from traditional batch processing because it requires systems that can handle continuous data flows with minimal latency while maintaining durability and ordering guarantees. For AI and machine learning applications, this enables use cases such as real-time model scoring, continuous feature engineering, and immediate response to defected patterns or anomalies in incoming data streams. All right. So Kinesis data streams. All right, so this is real-time data collection. So what are the core architecture and concepts? Okay, so Kinesis data stream serves as the foundational service for collecting and storing streaming data in real time, with the primary keyword being real time. For exam recognition, the service operates on the principle of immediate data availability, where records put into a stream can typically be consumed within less than 1 second, enabling near instantaneous response to streaming events. The architecture revolves around the concept of shards. Shards represent the fundamental unit of capacity within a data stream. Each shard provides 1 megabyte per second or 1,000 records per second of write capacity and 2 megabytes per second of read capacity. So this sharding model enables horizontal scaling by adding more shards to increase overall stream throughput, supporting workloads from small-scale applications to enterprise systems processing millions of events per second. Data within Kinesis data streams maintains ordering within each shard through partition keys, which determines which shard systems or shard receives, determines which shard receives specific records. Records sharing the same partition key are guaranteed to be processed in order, enabling applications that require strict ordering semantics for related events. So this ordering capability is crucial for machine learning applications that need to maintain temporal relationships in data, such as time series analysis or sequential pattern recognition. All right, and save these for yourselves. Okay. All right. Capacity modes. Okay. So there are several capacity modes. Provision mode requires explicit capacity planning where you specify the number of shards for your stream. This mode provides predictable performance characteristics and costs, charging per shard hour regardless of actual usage. Regardless of actual usage. Remember that for your cost monitoring. All right. Organizations choose provision mode when they have well understood traffic patterns and want to optimize costs through careful capacity planning. The mode requires monitoring throughput metrics to determine when scaling operations are needed. Then you have on-demand mode. All right. So this eliminates capacity planning by automatically scaling based on observed traffic patterns from the previous 30 days. The service provides default capacity of 4 megabytes per second and 4,000 records per second write capacity, automatically scaling up to handle traffic spikes. Billing occurs per stream hour plus data volume charges, making it ideal for unpredictable workloads or applications with high variable traffic patterns. The choice between modes significantly impacts both cost and operational complexity. Provision mode offers lower per unit costs for consistent workloads, but requires active monitoring and manual scaling. On-demand mode provides operational simplicity at potentially higher costs for high volume, consistent workloads. Data retention. Okay, so Kinesis data streams provides configurable data retention from 24 hours to 365 days, enabling applications to reprocess historical data when needed. This retention capability supports machine learning use cases like model retraining and updated algorithms, A/B testing of different processing logic, and debugging production issues by replaying specific time periods. The replay capability proves invaluable for machine learning workflows where algorithms evolve over time. Data scientists can replay historical streams to test new models, validate improved algorithms, or investigate anomalies that were missed during initial processing. This temporal flexibility distinguishes streaming architectures from traditional batch processing approaches. Okay. Security best practices. All right. So data protection includes encryption at rest using the AWS KMS, that's the key management service, and encryption in transit via HTTPS. These security features ensure data confidentiality throughout the streaming pipeline, meeting compliance requirements for sensitive machine learning applications like financial fraud detection or healthcare analytics. For high performance applications, AWS provides the Kinesis Producer Library, KPL, for optimized data ingestion and the Kinesis Client Library, KCL, for efficient data consumption. These libraries implement best practices for batching, retry logic, and error handling, enabling applications to achieve maximum throughput while maintaining reliability. Okay. Now let's see if we can do a test. This is... Now, I'm not going to create this fully, just letting you know. Data streams. Because you'd be in Kinesis, which if you went through the 9 side, I would think it's in... Wait, is it in data? Nope. Compute. No. Oh, it'd be under machine learning, right? No. Okay. Now, where would it be? Analytics? Yeah, there you go. Under analytics, boom. Real-time analytics. Okay. Go over here. See Kinesis data streams, select it here. Create the data stream. Oof, this is going to be scary. All right. We name it Kinesis test. All right. So you choose between the on-demand, which is what we talked about, the higher throughput requirements are under predictable and variable, or provisioned, where you can reliably estimate the throughput. Then you provision the shards, right? You can start with a single shard for testing. You can do an estimator here, and you're probably going to request a quota increase just because this is a lot of resources, and AWS limits you at first. All right, then you go down to capacity mode. Let's see. Yeah. So see this capacity mode, editable, provision shards, just one. Let's see, let me 5, 15. All right, data retention period, server-side encryption disabled. Ooh, that's interesting. All right, let's see what it looks like for on-demand. Server-side encryption disabled. Why would that be? You can edit it after it has been created in active status. That's interesting. All right, that is an interesting caveat. Okay, and then monitoring disabled, so you can add that, I'm sure. Data sharing project. Then you add your tags that are relevant, and you would click create, which we're not going to do. Okay, so the shard estimator does determine the appropriate shard counts based on the expected throughput. But then remember to consider both write capacity and read capacity, and plan for growth, peak traffic, etc. And you can set up CloudTrot, CloudWatch, and it looks like all the other pieces after it's created when it's in an active state. All right. Next, we're going to go to Kinesis Data Firehose. All right. This is a managed data delivery. So, all right. So the service architecture and provisioning. Okay. Let me see. Yeah, this might be a good one, but I don't see it. Let's see. Data doesn't really have data firehose. Uh, Not really a good architecture I see here. They're all here. Let's see. All right, this Here's a good architecture. Okay, so Data Firehose, formerly Kinesis Data Firehose, represents a fully managed service for delivering streaming data to target destinations without requiring custom consumer applications. The service operates as a near real-time solution, distinguished from real-time processing by its use of buffering mechanisms that optimize for efficient batch delivery rather than immediate processing. So the buffering mechanism accumulates records based on either size thresholds, typically 1 to 128 megabytes, or time intervals, typically 660 to 900 seconds, whichever is met first, whichever condition is met first, right? So this approach optimizes delivery efficiency and reduces costs for target services that prefer batch operations like S3 or Amazon Redshift. The trade-off between latency and efficiency makes Firehose ideal for analytics workflows where slight delays are acceptable in exchange for operational simplicity. So Firehose's fully managed nature eliminates the need to develop and maintain custom consumer applications, reducing operational overhead and development complexity. The service automatically handles scaling, error retry, and delivery confirmation, allowing teams to focus on data analysis rather than infrastructure management. Okay. Okay. So data transformation. So there's built-in data transformation capabilities that include, let me save that, format conversion from JSON to Parquet or ORC, or a compression using gzip or Snappy, and automatic data partitioning based on timestamp or custom attributes. These transformations optimize data for analytic workloads by converting to columnar formats that improve query performance and reduce storage costs. Then there's custom transformations that leverage AWS Lambda functions to implement sophisticated data processing logic before delivery. So common use cases include data enrichment by joining with reference data sets, format normalization for heterogeneous data sources. Then you have filtering and sampling for cost optimization and data validation with error handling. Lambda integration enables virtually unlimited transformation possibilities while maintaining the managed service benefits. Then you have error handling and backup. These mechanisms automatically route failed transformations to S3 buckets for investigation and reprocessing. This capability ensures data durability even when transformation logic encounters unexpected data formats or processing errors, supporting robust machine learning pipelines that can handle diverse and potentially malformed input data. All right. Okay. So destinations. So you see all of these, right? So there's a lot of destinations that can be configured, right? Here's the ecosystem. I'll break it down as simply as possible. There's AWS native destinations. This includes S3 for data lake storage, Redshift for data warehouse analytics, OpenSearch for search and analytics use cases. These integrations provide turnkey solutions for common analytics architectures without custom development. Then you have third-party partner destinations. This would be Datadog, Splunk, New Relic, MongoDB, and these enable integrations with existing enterprise tool chains. These partnerships extend AWS streaming capabilities to established analytics and monitoring platforms. And then you have custom HTTP endpoints. And this provides flexibility for destinations not covered by native integrations, and it enables delivery to any system capable of receiving HTTP requests. So this extensibility ensures that Firehose can adapt to diverse architectural requirements and proprietary systems. All right. Let's close this. Okay. Let's see. So how would we do this in Kinesis? All right. So data Firehose, new, formerly Kinesis data Firehose. All right. You would create this. All right. You choose a source type. Okay, so you can have a couple of ones. You have Kinesis data stream, which we were just talking about, MSK, and then you have the direct put, right? So let's do this. Yeah, and then we'll do a destination. This could be for S3, for Redshift, open source, or a third-party service like we previously chose. So let's go for S3. All right. The stream name, something unique. Look at that, uppercase and lowercase, numbers, underscores, hyphens. Data stream, which we would have created in the previous run. And then what are you doing as far as transformation? So you can enable a built-in format conversion if needed. So like JSON to Parquet or ORC, all right? So, turn this on, right? Add the Lambda, right? You can set up a Lambda function for a custom transformation. And you have the buffer size. You have the convert the record format conversions. You have the turn on the decompression, right? For a message extraction right here. So this is, okay, so This is Firehose decompresses CloudWatch logs and delivers them to the destination. Additional fees, so you might not need it, okay? And the destination settings. So select an S3. We have some here. All right. Let's see. Where is format? Did I miss format? Oh, comport the format. There we go. Okay, so the output format. Okay, output format. This is what I'm talking about. The Parquet to orc. That's where you would convert that. So you can do this for more efficient querying. That is why it's valuable. All right, it compresses it down, makes it work better. And then you have your buffering, which we showed. The buffering based on late is how you adjust the size and interval settings based on the latency requirements and destination. All right. You set that to the bucket of your choice, dynamic partitioning to create targeted data sets by partitioning your S3 based on partitioning keys. You can partition this inline or specify with the AWS Lambda. And dynamic only when you create a new Firehose stream. Okay. So this is probably for more efficiency. And more, okay. And then S3 buckets appends a prefix to the data. Okay, so you can make a custom prefix as well to separate this out. And then S3 error output prefix, that would be very useful. You know, something like error. Prefix would be stream 2025 12. Yeah, that would be suitable. All right. And so, you know, that would just be an example of what you'd want for December 2025 streams, right? Buffer hints, expressions, file extensions, error zone, Firehose buffers incoming records before delivering to the record. So this is the batch portion of it. The buffer size, so that 1 to 128, defaults at 5, 90, was it minimum 0 seconds? Ooh, maximum 900. So that 300 seconds is the default, okay. And then compression for data records, okay. So compress this before sending this. This is what we talked about there. I do something like gzip, but we're going to set it to not enabled. Final extension, so let's say .json, all right, and specify extensions. It will override default extension set. Ah, okay. There's on that commercial or that conversion. All right, and then backup settings. And so you can have backup so that data can be recovered if processing fails. So this is the error handling portion. And advanced settings, this is the CloudWatch for error logging as well. Boom, enable this. And you could create an IAM role for this or choose an existing one. Tags is necessary and then create this. But since we don't have a data stream up here, it likely wouldn't create. Okay. So we're going to cancel. And continue. Okay. Next up, we're going to go Amazon Managed Service for Apache Flink. So some evolution portions. All right. So Amazon Managed Service for Apache Flink represents the evolution of Kinesis data analytics. So this is transitioning from a proprietary SQL-based analytics service to a managed implementation of the open source Apache Flink framework. The evolution reflects AWS's broader strategy of embracing open source technologies while providing managed service benefits. The transition from Kinesis data analytics to managed service for Apache Flink provides expanded language support beyond SQL, including Java, Python, and Scala. This expansion enables more sophisticated stream processing applications that can implement complex business logic, machine learning inference, and advanced data analytics that would be difficult or impossible to express in SQL alone. So the Flink fundamentals include support for both bounded or batch and unbounded, so streaming data sets. Exactly once processing guarantees and sophisticated state management capabilities. These features enable complex event processing applications that maintain accuracy and consistency, even in the face of failures or processing delays. Okay. Okay, so let's go for stream processing. Okay, some of the stream processing capabilities include this: stateful stream processing, which enables applications to maintain context across multiple events, supporting use cases like sessionization, pattern detection, and complex event correlation. For machine learning applications, stateful processing enables techniques such as sliding window aggregations, real-time feature engineering, and maintaining model state across prediction requests. And then you have complex event processing, which supports sophisticated temporal patterns and correlations across multiple data streams. And applications can detect sequences of events, identify missing events, and implement complex business rules that span multiple data sources. This capability is essential for fraud detection, system monitoring, or behavioral analytics. And then you have integrations with machine learning services. So this would enable real-time model scoring by integrating with Amazon SageMaker endpoints, Lambda functions, hosting lightweight models, or embedded model artifacts within Flink applications. And this integration supports use cases like real-time personalization, anomaly detection, and predictive maintenance. This is where you get really good with some security stuff. Okay. So data sources. All right. So Flink sources include Kinesis data streams for high throughput streaming data, Amazon MSK for Kafka-based architectures, and various data sources through custom connectors. This enables Flink applications to process data from multiple streams simultaneously, supporting complex analytic scenarios. And then you have Flink syncs. Okay. Let me see. I have this. Oh man. Oh, is that it? No. Okay. Okay. Well, Flink syncs. Okay. So Flink syncs deliver processed results to destinations such as Kinesis data streams for further processing. And so Kinesis data Firehose for data lake delivery, or S3 for direct storage, and different databases and analytics service. This sync ecosystem enables integration with downstream machine learning and analytics workflows. And with application deployment, this will occur through S3 hosted jar files or Python scripts, and it'll enable version control, automated deployment, and rollback capabilities. So this deployment model can support MLOps, like machine learning operations practices, and can enable sophisticated CI/CD pipelines for streaming applications. And then we have something like random cut forest. All right. So random cut forest, this is an algorithm that represents AWS's contribution to real-time anomaly detection in streaming data. So it's available as a SQL function with Flink applications, and random cut forest providers, or RCF, this provides unsupervised anomaly detection on numeric data streams without requiring pre-trained models or labeled data sets. And then RCF will operate by constructing an ensemble of decision trees that randomly partition the data space with anomalies identified as points that require fewer cuts to isolate. So this approach proves effective for detecting outliers in time series data or unusual patterns in user behavior. And then the system performance can also detect different anomalies as well, right? But there's some implementation considerations that include the algorithm's ability to adapt to changing data distributions over time. So it makes it suitable for dynamic environments where normal behavior patterns evolve. And then there, the algorithm requires minimal configuration while providing pretty interpretable anomaly scores that can drive automated responses or prompts for human investigation. Okay. Amazon MSK. All right. Managed streaming for Kafka. Okay, so MSK provides a fully managed Apache Kafka service that eliminates the operational complexity of running Kafka clusters while preserving full compatibility with the Apache Kafka ecosystem. So this compatibility ensures that existing Kafka applications, tools, or connectors work without modification, and then enables organizations to migrate existing Kafka workloads to AWS or adopt Kafka for new streaming applications. So the Kafka architecture components include broker nodes, and those will handle data storage and pre-processing or processing. Then you have zookeeper nodes that manage cluster coordination and topic partitions, and they'll enable horizontal scaling and parallel processing. And so MSK will manage all these components automatically and handle tasks such as node replacement, software patching, and capacity scaling. And then you have multi-availability zone deployment. And this will distribute Kafka brokers across multiple AZs for high availability and fault tolerance. And the data replication occurs automatically across AZs, ensuring that streaming applications can continue operating even if an entire AZ becomes unavailable. This is crucial for production machine learning that requires continuous data processing. Okay, and this is the big boy. You're going to read all this, right? If you want to get into Kafka, all right? But yeah, we're going to go forward with, okay, so there's some configuration flexibility with this. So unlike Kinesis data streams, MSK enables extensive customization of Kafka cluster behavior, including message size limits, retention policies, and performance tuning parameters. And so the default message size limit of 1 MB can be increased to 10 megabytes or more. And it supports applications that need to stream large payloads like images, documents, or complex data structures. So within this, recognize there's a broker instance type, which range from general purpose instances for development workloads to memory optimized and storage optimized instances for high throughput production environments. And this flexibility enables cost optimization by matching instance characteristics to specific workload requirements. And you have storage configurations using EBS volumes. And this can range from 1 GB to 16 terabytes per broker, with options for different volume types to optimize for cost or performance. And the storage flexibility supports long retention periods for applications that need to maintain historical data for model training or compliance requirements. Okay, so security, my bread and butter. So MSK implements security controls that exceed those typically available in Kinesis data streams and supports enterprise security requirements and compliance frameworks. So one, mutual TLS authentication. This uses client certificates for both encryption and authentication, and it provides a strong identity verification without requiring external identity providers. So this approach works well for machine-to-machine communication where certificate management is feasible. Then you have SASL and SCRAM authentication. So this provides username password authentication with encrypted credential storage, offering a balance between security and operational simplicity. And this mechanism works well with existing identity management systems and credential rotation processes. Then you have IAM access control. So this enables authentication and authorization using standard AWS IAM policies, providing integration with existing AWS identity and access management frameworks. So this approach simplifies security management for applications already using IAM for other AWS services. And then you have Kafka ACLs, right? So this is a fine-grained authorization at the topic and operational level, and it enables complex multi-tenant scenarios where different applications or users require different levels of access to streaming data. ACL support enterprise scenarios where data governance and access control are critical requirements. Make sure you save that one. All right, and then MSK serverless. Okay, so MSK, there's two parts of this. MSK Connect, this provides managed Kafka Connect workers that eliminates the operational overhead of running connector infrastructure. And it connects and so Connect workers can pull data from Kafka topics and deliver to destinations like S3, Redshift, open source, or source data from external systems into Kafka topics. Then you have MSK serverless, right? So MSK serverless removes the need for capacity planning by automatically provisioning and scaling resources based on actual usage. The mode provides a consumption-based pricing model that can be more cost-effective for variable or unpredictable workloads while maintaining Kafka compatibility. Okay. Let's go performance tuning. This is right sizing. Okay. All right. So you have first is producer side optimization, right? So let's see. Yeah, let's see if we can get. Let's go up here. Let's start. I think this is it. Yeah, that's a good image as well to have. Okay, so for producer side, throughput optimization focuses on batching records efficiently, choosing appropriate partition keys for even distribution across shards, and implementing retry mechanisms for transient failures. The Kinesis Producer Library, or KPL, provides built-in optimization for these concerns. It automatically batches records and implements exponential backoff for retries. Then you have hot shard detection, right? So This involves monitoring shard level metrics to identify uneven data distribution that can create performance bottlenecks. And solutions include implementing more granular partition keys, using random partition strategies for uniform distribution, or increasing the number of shards to handle concentrated traffic. All right. Then you have error handling strategies, right? So this includes implementing the exponential backoff, like we talked about, or a monitoring service for service limits and quota utilization. And you can use that to ensure adequate provision capacity for traffic patterns. And then these can help prevent cascading failures and ensure reliable data ingestion. Then you have the consumer side optimization, right? Let's see. Hmm. Okay, let's try this. Uh, let's look around. That could be okay. Yeah, that could be okay. All right. So first you have the scalar consumer of applications, right? So this involves increasing shard counts for higher aggregate throughput, and then optimizing the record processing logic to minimize per record processing time, and implementing proper checkpoint management to handle failures gracefully. Then you have the enhanced fan out. All right. Oh, all right, enhanced fan out. So this provides a dedicated read capacity for individual consumer applications, and it eliminates the shared read capacity limitations of standard consumers. This feature is particularly valuable for machine learning applications that require guaranteed read performance independent of other consumers. And then you have a KCL configuration. So this includes proper settings. Let me see if we can. Yeah, it's not on this one. Proper settings for release management, worker allocation, and checkpoint intervals. And proper configuration ensures efficient resource utilization and minimizes the processing delays due to coordination overhead. So this is right sizing it, right, on both ends. Okay. Okay. And there's a little bit about monitoring, but we're going to do this. Okay. So this is the one about it. Okay. Um, all right. So monitoring. Okay. So a couple things. CloudWatch metrics provide comprehensive visibility into stream performance. This includes put or get rates, throttling exceptions, iterator age, and consumer lag. These metrics enable proactive identification of performance issues and capacity planning for scaling operations. And then you have application level monitoring, which includes the tracking custom business metrics, or you can monitor data quality and completeness, and you can implement alerting for anomalous conditions, right? So this is a type of monitoring that complements the infrastructure metrics to provide end-to-end visibility into the streaming applications. And then let's go into optimization. So cost optimization. You have a couple of things here. Service selection optimization, right? So think of Kinesis versus MSK trade-offs. This centers on operational complexity, customization requirements, and cost models. So Kinesis provides simpler operations and managed scaling, but limited customization options. MSK offers extensive customization and potentially lower costs for large-scale deployments, but requires more operational expertise. Then you have capacity mode selection. So for Kinesis, this involves analyzing the traffic patterns to determine whether provisioned or on-demand nodes or modes provide better cost efficiencies. And provision mode favors consistent, predictable workloads, while on-demand suits variable or unpredictable traffic. All right. Then you have retention periods. So with this, you have to balance data availability requirements against storage costs. And then remember that shorter retention periods reduce costs, but limit replay capabilities. So that limits that functionality. Then you have longer retention supports comprehensive reprocessing, but it has a higher storage cost. All right. And usage patterns. So usage pattern optimization, right? So there's a data transfer optimization that includes minimizing cross-region data movement and batching records to improve efficiency. If you use this compression where applicable, you can reduce bandwidth requirements. And you also have to concern yourself with processing efficiency. So this involves optimizing transformation logic to reduce compute costs and implement efficient serialization formats and eliminate unnecessary data processing steps that don't add value to downstream applications. All right, let me go. Let's see if we can walk through an MSK cluster, fully managed. All right. Well, All right, so we'll go here to MSK. All right. All right, so here we're going to select the type we're going to go. So MSK cluster. All right, we're going to type what type of instance do we want? Quick create or custom create? We're going to do quick create. Okay, we're going to do cluster name. All right, then we're going to do the cluster type, serverless or provisioned. All right, so what's the difference here, right? This option allows on demand, so the scales, and this allows you to specify the number of brokers and amount of storage. So you're going to pay upfront, or you're going to pay on the back end, or you're going to have good scale. All right, so we'll do serverless. Yeah. Whoa. It's editable after. All right, so that's fine. The most important thing is to look through here. Okay, look at the right, 200 megabytes per second. The read, 400 megabytes per second. Cluster storage, unlimited storage per partition, maximum number of partitions, 2,400. All right, and then here's some security settings, which will only be enabled after it's completed. All right, so you want to look at the cluster type, serverless, VPC. It looks like it's going to the default. Subnets that are available, security groups, right? So you want to be able to set up this so you can have guided and limited transmission of data, right? So you're thinking about your mutual TLS, SASL, Scram, IAM, access control with IAM, right? And you can set up appropriate ACLs or IAM policies for access list controls, right? And then once created, you could, which we're not going to create, right? Then you can set up CloudWatch monitoring for cluster or topic level metrics. And you can set up delivery to CloudWatch S3 or Kinesis data streams and configure like maintenance windows along the time, okay? Okay. Let's see. All right, that's here. All right. So how do you work this with AI or machine learning? So there's real-time feature engineering. So streaming services enable real-time feature computation that can immediately serve machine learning models without the delays associated with batch processing. And features can be computed on sliding windows, aggregated across multiple data streams, and enriched with reference data to provide up-to-date inputs for model scoring. And then you have implementation patterns. This includes using Flink for complex windowing operations, Lambda functions for simple transformations, and Kinesis analytics for SQL-based feature computation. These patterns support different complexity levels and operational requirements. Then, let's see. Is it here? Nope, it's not. Okay, next one. Then you have model scoring, okay? So this is feature store and model scoring, right? Streaming architectures enable real-time model scoring by integrating SageMaker endpoints, which we talked about, or Lambda-hosted models or embedded model artifacts. So this integration supports use cases requiring immediate responses to streaming events, like fraud detection, recommendation engines, or dynamic pricing systems. So with this, you also get latency optimization. And these techniques include model preloading, connecting pools to inference endpoints, and batch scoring for improved throughput. And these optimizations can balance responsiveness with cost efficiency. All right, and then finally, we have the machine learning ops integration. All right, so streaming services will integrate with machine learning operations workflows by providing the data lineage tracking, the A/B testing of different models, and automated retraining pipelines to be triggered by data drift or performance degradation. And then within this, you'll have deployment patterns. So you could do a blue-green deployment for a streaming application, a canary release for a gradual rollout, and automated rollback mechanisms for failed deployments. And these patterns can ensure reliable operation of production machine learning systems. And we've gone through a lot of the documentation just on a surface level, but I've walked you through it verbally so you can go through it. What we're going to do next is a little touch into some of the data transformation and go over the EMR. But I hope you enjoyed this. And if you know anybody who is looking to take the AWS Machine Learning Associate, hit the like button, share this with them, and subscribe. But until then, have a good day. Thank you.